Hey everybody, welcome back. It's lecture number 10. We're going to be talking about visualizing data. As you may remember, a good chunk of a data scientist's work is going to be in communicating the analysis that you've done. And one of the most effective ways to do that is with a visual representation of data. So we're going to get into some do's and don'ts, but first, let's get into some exams because I know everybody is concerned. Okay? So let's take a look. Course reminders. So your reading quiz number 2 is due today. I'm sure that you all probably have mostly finished that because I'm sure that exam number 1, the midterm number 1, is weighing on you a little bit. Okay, let's go through some items. So first and foremost, it's going to be, whoops, making noise on the mic. It's going to be on Monday, the 26th. We will send out a reminder so that you will make sure that you do it, okay? The test is going to be on Canvas. It's going to look a lot like the reading quizzes you've taken. It's going to have that same interface, okay? The test is going to be available for you to take from 12:01 a.m. through 11:59 p.m. So an entire 24 hours. So that should handle our people who are in different time zones and so on and so forth. Once you start, however, you're only going to have 90 minutes to finish. The exam is designed to take 60 minutes. So we're assuming that because internet, that you might have some problems that need to be dealt with. That's why we're giving you some extra time. So once you start this, make sure you finish it in the right amount of time. If there are questions, the kind of thing you might raise your hand to ask an exam proctor about during an exam, give us a private message on Piazza. Send a private message to the instructors. We are going to have somebody on call 24 hours throughout the whole Monday. So one or the other of us will be there to answer a question. We're aiming to answer questions in like less than a minute, less than 5 minutes for sure. Okay? So privacy notice, we are going to know if you leave this web page to go elsewhere. Okay? If you stop and go, the thing that I'm going to get most upset about is if I see that you stop and send some emails, then I might be thinking that you're sharing information with other people, right? But know that in the end, if you are doing something like opening a browser so that you can look at the de novo paper, I'm okay with that, okay? The notice for the privacy, that knowing that Canvas keeps track of what you do, is more for your privacy than anything else. I want you to understand that the Canvas thing understands when you stop interacting with it and that you've gone off and paused and gone to do something else. Okay, so again, I don't care. This is an open everything exam. You can have the de novo paper in front of you. We're thinking that a lot of the exam is fundamentally about what you think and what you understand. It's not, a lot of it is not factual. Also, I want to trust you, right? I'm not using every tool that I have available to me to prevent you from cheating. I'm leaving open a great huge chunk of the, this 24-hour window. Obviously, I am worried that people who take it early might communicate with people who take it later. I hope you will not do that. I hope you will abide by academic integrity. Because in the end, I don't have full control. No matter what I do, there are ways you can cheat. I don't want you to cheat because I want you to learn and to demonstrate learning. In the end, the only person you're cheating is yourself 3 years down the line when you don't know the things you need to know. Okay? So, that's about all I have to say on the exam. Oh, except that it's going to be in the neighborhood of 50 questions, and it's going to be largely multiple choice or something like that. There's not going to be any essay questions or something like that. We're going to cover in a minute what you should study. All right, so don't freak out. About a third of you have not signed up for a final project group. So we are going to be assigning you all to random groups of 4 to 5 people. Now, the next big thing coming up after the exam is assignment number 1. It's due on the 6th of November at midnight. Okay? I think that in a previous iteration of the syllabus, I said that everything was due on Thursdays. I don't want assignment 1 to be due on Thursday. I want assignment 1 to be due on Friday to give you that extra day to work on it. Okay? So fundamentally, we are going to cover assignment 1 and what's up with that in discussion sections. There's going to be a guide released to help you through assignment number 1 that will be on the web, if not tonight, Friday night, then Saturday. Okay, it'll be on Canvas. But the only reason it's going on Canvas is so that you can have a mental load off and you're not going to end up, worrying about what this is about when you're on the midterm. I want you to chill out with the assignment number 1 until after your midterm is done. Okay? Also of note is that material from today's lecture is not going to find its way into the final exam. Sorry, into the midterm exam, because there is no final exam. You should read your own syllabus, Jason. All right. So the material today is for midterm exam number 2, not for this one. All right. Well, if that's about all, let's take a look at exam number 1. So we've had 9 lectures. We are going to cover something from all of them in the exam. Every one of those lectures is getting some questions, as well as both readings. Okay? So my goal with the exam is for you to understand the topics. Okay? Not to be able to just regurgitate factual information. So I may ask you, is this a good example or a bad example of whatever thing? I may ask you, is there some sort of comparison to be made between X and Y? I may ask you why this is not a good version of X. Okay? Those are the kinds of things you're going to get asked about. So things that require you to think, not just regurgitate some sort of figure. Now, if you look at all 9 of these lectures that I have on the screen here, and you look in the beginning of the lecture at the learning objective slide, that's at the front of almost all of these lectures, then if you feel comfortable that you can meet that learning objective, then you should feel comfortable that you will do very well on the test. All right. So there is already a study guide, which is here, released for you on Canvas. Go take a look. So it's not an exhaustive list of everything that could be on the exam, but it gives you a sense of the things that we are concerned about. Okay? I'm not going to go through this. You go look at this on Canvas. So when you go to study, review notes that you have from the lecture. You can re-listen to it on the videos. You can review the clicker questions. They might also give you a sense of the kinds of things we're going to ask. Okay? Now, along the lines on the clicker questions, here are some that we did where the response was not overwhelmingly the correct response. Okay? So data scientists and computer scientists program a little differently, which describes a uniquely data science programming task. Now, the vast majority of you got the right answer, right? You got the fact that it's data wrangling. But I'm a little concerned at the 25% of you who didn't quite realize that. Of course, this question was asked before we had an entire lecture on data wrangling, so I think you'll probably do a lot better now. Which of the following is not a reason to version control your projects? Well, again, the vast majority of you answered the correct answer, saving a complete copy of a file every time it changes, right? That's not what version control does. It doesn't save a complete copy of a file. It saves a delta, the small change that happens between versions. And it lets you run that history backwards and forwards by applying the delta or unapplying it. Okay? So that's not a reason. We don't save complete revisions, complete copies of the file. We save the deltas between revisions. So again, most of you got the answer right, but I just wanted to make sure that the 25% of you who missed it understood what that was about. So this is another one where most people got the right answer, but the answer is all of the above. So each one of these is an element, and some of you missed that. Which of the following is the best file name? Well, there is stylistic difference here. This is open to opinion. However, there is a couple of things to note here. So I would say that these two are equivalently good, that the difference between these two is stylistic. Okay? It is the case that we are calling out the blue answer, the one most people picked, the plurality picked. But, you know, the important elements that make these good is that the number one implies there's a natural order here. Okay? It implies that we want you to look at this one first, then O2, then O3, then O4. Well, fine. If you want me to look at those first, put that in the beginning so when you do a file name sort, that we show O1, O2, O3, O4 in that order. Okay? And the stylistic difference is the underscores versus camel case. And as I mentioned in lecture, camel case is just somehow passé now. It's not that it's wrong, it's very legible. It's just not the fashion right now. All right. So this is another case. Almost everybody answered the right way, but 25% of you kind of got the wrong end of it. And this is one which is due to me, right? At some point in one of the lectures, I mixed up replicability and reproducibility when I was talking. So I just want to be super clear. You reproduce when you take code and software and data and redo it with your own hands. That is a reproducibility study. Okay? You replicate when you take the same methods and hopefully the same software and you apply it to brand new data. That is a replication. Okay? So this, you really see an awesome, really awesome result and realize you have the same data, but from a different group of people is what that goes on to say. So you use that method and you replicate the original result. Okay? The blue, really awesome result, you get the group's data and rerun their analysis. That's reproducibility. Okay? Alles klar? Then, okay, here's another one where it might be hard to believe because there are 300 flowers, but that is still a categorical variable. There are 300 different categories of irises, so it's a categorical. And finally, this one is also kind of my fault, and I want to be super clear. So I said during the lecture that depending upon the study you look at, people say that they spend between 50 and 90% of their time doing data wrangling. Well, that doesn't line up with these categories, okay? And I was speaking from slides which clearly indicate that 60 to 80% is the right answer. Okay, so that's the right answer, is 60 to 80%. While it is true that you can find studies out there that say differently, let's go with the fact that 80 to 100% is definitely the wrong answer, because nobody gets anywhere close to 100%, I hope. That would be a terrible job. And the 40 to 60% is not good, because that means that, we've got, again, less than half is in that range. So just from like a logical standpoint, and the fact that it's dead in the middle of the range that I mentioned, in a situation like this, I think you should pick 60 to 80% as the answer. Okay? All right. So, you need to know the reading R1, and we need you to look over the exam study guide. Okay, the exam study guide, like I said, is already on Canvas, and good luck with that. If you have questions over the weekend, feel free to ask on Piazza. Okay? So let's get on to the nitty-gritty of the actual day. Today's learning objectives, we're going to make sure that you can explain why you would use one viz instead of another for a particular kind of data. We want you to be able to understand and interpret graphs and tables effectively, and flip of that, be able to produce graphs and tables that other people can effectively interpret. Okay? So we need you to understand how to interpret them so that you can think about what it's like to be in somebody else's shoes and try to interpret this mess of a graph that you just made. Okay? And we also want you to be able to, along with that, diagnose what's problematic when you see it. Okay. So first I'm going to go through a bunch of different types, right? We're just going to kind of bang, 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 just so you see them. You've possibly seen all of these before, but we just need to make sure that everybody's coming to the same page with an understanding of what graphs look like. Okay? So in the course of showing you this data, so I'm going to keep using the same data, and we're going to show you different visualizations with it. And it's all coming from this data set about self-reports of height and weight. Okay? So this data set contains essentially, it's about people, and it's coming from a study about people's body images and their preoccupation with their weight. But all we care about is the numbers, not the science behind it. Okay? And you can see here that we have sex, weight, height, and also a reported weight and height, which is potentially different than the actual weight and height. All right. So this is what the data looks like. It's a big tabular data set. So one of your bread and butter graphs when you're looking at a data set is to see what did the numbers look like across all the data. Okay? So we have 4 different variables there. Let's pick one of them, height. Okay? And let's see, what does the group of people look like in height? So a histogram helps you answer that question. What is the distribution? What is the setup of this data across all of our samples, all of our observations? Okay? What do you see here? You see along this axis, this is height. Okay? And along this axis, this is a count. All right? So what this says is that people near 200 centimeters tall, we have about 5 of them in this data set. Well, no, not even, like 2 maybe 1. Okay? It's hard to see at that low a number, but the height of this bar says how many people have that height. Okay? So a histogram lets you easily visualize the range of possible height values in this data set. We can see, for instance, where most people lie. Okay? So around 40 people are in a particular height range, around 165 to 170 centimeters tall. We can easily see what the upper and lower ranges are. We can see how variable we are within the group. Okay? Now, these two graphs are very similar. Okay? The difference between a histogram and a density plot is that the density plot makes some smoothing on the histogram. It fundamentally comes from this idea that you'll come up with, as you get into statistics, of population and sample. Okay? There's a big population of people out there whose height we're exploring, but we don't have everybody in the population's height. We have these 300 people that we've recorded, and so they are a sample of the whole population. And we know that a sample is kind of a random draw. We didn't necessarily systematically go out and get these people, we kind of got them by chance. So there's going to be some noise and jaggedness in that histogram, which doesn't truly represent the whole population. So by smoothing away that jaggedness, we're making an implicit assumption that there's an underlying smooth distribution of all 375 million Americans, or whatever the data set's supposed to represent. Okay? So that's what a density plot does. It smooths the histogram. Okay? There's lots more detail to that, but as you get into visualization, we'll cover that more. There's a parameter about how much smoothing you do. Okay? And changing that parameter changes what the density plot looks like quite a bit, potentially. Density plots are for when you have a lot of samples. They're not for when you have 10 samples. Okay? 10 samples, use the histogram. All right, so again, we have the same kind of information. We see that most people are around 160 centimeters tall. We can see that there's some weird outliers. Okay, you could see that in the histogram too. Okay, another example is when we want to know what the relationship is between two numerical variables. So height and weight. We can plot them x, v, y. You're almost certainly very familiar with this kind of plot. And what's good is that you can see that there might be some trend here by eye. Okay? There's a lot of subtleties to that we will get into a little bit more later, but fundamentally, if you want to see if there's a strong relationship, this kind of a plot will help you see that. Now, if what you have is not numerical values, but counts within a categorical variable, then you want to use the bar plot. The bar plot and the histogram are highly related. They both consist of bars, right? But the bar plot is just, two things like female versus male instead of having this be over a continuous variable binned up, okay? These are inherently categorical variables, female or male. And I'm talking about the data here. I'm not talking about the fact that gender is actually a binary. So don't get me in trouble, please. All right? But the data is categorized strictly as female, male. All right. So in this kind of a thing, it's very easy to look at a difference in relationships between the two categories. Okay, so little quiz time. Here is a pie chart. I know I'm showing you a pie chart for the first time. But which segment do you think is the third largest segment here? As you might guess, pie charts seem to find it's not really a great thing to ask with a chart like this. It's quite hard to see by eye. Now, with a bar chart, which segment is the third largest? Now, as you've probably figured out, this is a relatively easy task with a bar chart. So here's a little study that shows you exactly that. For 54 people that were judging a bunch of different charts in either pie or bar format. The task was to judge which segment or bar is the largest. And people did a lot better when we had position, so versus angle information. So angle is the pie chart. So when comparing magnitude, bar charts are way better than pie charts, just like you experienced. All right, let me explain this graph here because we're about to go into that. So this is the mean value of people who were looking at the bar chart, okay? This is the mean value of people who were looking at the pie chart. And around those mean values are whiskers. And those whiskers show an estimate of the error associated with that mean value, okay? Statistics time, you guys are not yet through any kind of statistics course probably. But remember that we have this random sample, right? Like I was talking about, there's a bunch of real people out there. We get a small subset of them to get our data from. And so by chance, we could pick a few extreme people, people who are way lower or way higher in ability at seeing these bar charts and pie charts. So whatever estimate we get from our sample, from these few people, the 54 people, right, is we're asking, how does that compare to where the real population of everybody is? So those whiskers are a statistical method of showing you what your uncertainty is about where that true mean of the population might lie. The population of everybody assumedly lies somewhere within these whiskers, okay? This is what the mean was of our actual data from our 54 people, but because of random chance, those people might not be completely representative of the whole population. So we figure that the whole population is somewhere inside this range. Okay? So by saying that, we're quite certain that this is way better than this because there's no separation. We know that there's no possibility that in the full population, those things are the same value. Okay? Don't worry too much if you didn't understand that explanation. Like I said, that's the kind of thing you're going to have to take a stats course to fully understand. But trust me when I say that pie charts generally not good for almost anything. Okay? Now, the chart I just showed you is an example of a box plot. So this is a box plot, okay? Or it's one form of a box plot. A box plot shows us how variable a given measurement is, okay? So for women, females, it looks like the most common height is in the neighborhood of 165 centimeters. For males, it looks like it's in the neighborhood of 177 or so. Okay? So that's what that big dark line is. It's the most common. It's the median, to get you, those of you who know some statistics, it's the median measurement. Okay? Then out to the edges of the box, inside that is half of all the data. So if I was going to start to draw data points, okay, those little dots are measurements that we actually have in our data set. Half of them are going to lie within that box. And half of them are going to lie outside it. Okay? So that's what we're describing with a box plot. So the box contains half the data. It shows you where most of the data lies. The middle of the box, that line, shows you the median, the middle value in all the data. Okay? These whiskers show you, these are the edges of what we think is normal. okay? And if you have any circles like this down here, those circles which are outside the whiskers, they only appear outside the whiskers. Those are outliers. By a certain statistical definition, they are very weird compared to the rest of the data, okay? So that is branded as something that you might want to take a closer look at. It might be not an adult woman, it might be a 12-year-old, okay? Might be something outside of the category that you think you're dealing with. Or in this case, perhaps somebody with a medical condition that makes them particularly short. All right, so this is just the rest of these slides just go through what I already told you. The middle line represents the median, tells you the typical height. Okay? These lines give you the ideas of the typical range of values. And values outside that typical range are shown as outlier circles. Okay? Tables, everybody loves tables. So they do count as data viz. They are ways to show the data off. You have to be careful on using tables because obviously they can grow so big that they become very difficult to understand. Tables should still show you some kind of summary of what the data is, rather than all the data. Okay? So here's a little website I encourage you to visit. It shows you when you say, what kind of data do I have? I have categorical data, or I have numerical data, or I have a bunch of different variables that are numerical. And my goal is to do blah, blah, okay? Then this website will lead you to, this is the right kind of visualization in order to show what you're after, okay? It'll lead you to it, and it will even give you some code to build it in different programming languages. Okay. So let's do some testing. Let's see how well you understand. So I'm going to let you visit several of these and give your response on the Google form. If you don't have access to the Google form, just go ahead and press pause and think before you just go on with this. Come up with your own answer. All right. Well, let's talk about ways to do things right and not right. So we've already talked about this, right? Pie charts, just leave them alone, okay? I can't really think of a really solid use case when a pie chart is absolutely the right answer. All the cases when it's an okay answer, there's something else which is just as okay, right? Bar charts make it much easier to see differences between groups like we talked about. So another issue may be color blindness. Like 10% of the population is colorblind to one extent or another. Okay? Red-green colorblind being the most common. I actually, during my PhD, I diagnosed my office mate as being red-green colorblind. He never knew he was until I showed him a plot. And he said, so you mean this green thing? And I was like, no, it's red. It's like, no, it's green. So, at any rate, colorblind individuals can't see the difference between red and green on charts, especially when the features are fine, like a tiny little thin line, like in the case of my Brazilian office mate, who, when I made the line and the graph like 10 times as wide, he could see which color it was. But when it was a really fine little line, no chance. Okay? So, if you want to be kind to 10% of the population, which is a pretty reasonable thing to do, there are particular color palettes that you can pick, which are much better. Okay? Most software packages for making data viz have as a setting, choose by default colors for things like lines and categories like we have here, choose colors that are colorblind friendly. Okay? If you're just giving it to, 10 people who none of them's colorblind, okay. But if you're doing things for public consumption, it's good to think about. Accessibility in general is good to think about because we're going to come up with some other stuff soon. So this is, people should be able to look at your graph and understand what it's about, okay? If they, they may encounter your graph in the absence of any words that you have surrounded it with in a report. So the graph should speak for itself. Often, people, especially busy people, will, when presented with a report of any kind, not actually read it. Shock, right? You spend, 2 weeks making this really important report, and you give it to some important executive or your PhD advisor or something like that. They may skim it if you're lucky. And if they skim it, what are they going to do? They're going to look at the graphs. And they're probably not going to read the words near the graphs either. Okay? So always make sure that your data viz stand on their own, that they're fully labeled so you can understand what they're about. Now, this is what I was saying about accessibility. Okay, I'm getting old enough that I'm starting to do this, right? Like little tiny things on a retina screen, like little print. Yeah, I mean, I can't bring it close enough to see it anymore. So be kind to old people like me, okay? Make nice big fonts. Make sure that the labels are clear for a variety of users in a variety of situations. So something that might be legible on your computer screen might not be legible on a different device. Okay. It's always good to make sure you don't have numerical mistakes, right? 75 plus 20, not 100. Make sure your numbers add up. Make sure the numbers you put on something actually represent the chart. So in this case, there is a strong mismatch between 55% and the fact that that's only showing you a quarter of the area. Okay? So make sure that you don't have a mistake in creating your viz. That's the usual reason why this kind of thing happens. Usual. Okay, make comparisons easy. So both in terms of aesthetics and in how you pick to present the data. If you know that the reason you're showing something is to make a comparison between Group A and Group B and Group C, pick the right format and pick the right aesthetics so that your eye naturally sees these things. Now, there is a whole bunch of good information out there on how to do this kind of stuff, and we're going to talk about some of it, but right now, this is high level. You need to think about these things, okay? A classic is the unrooted y-axis. So the unrooted y-axis is an old problem where if you start something at, most of the way up the bar, it can make small differences look big, right? If you think about extending those bars down 200, right? This is a tiny little proportion up here of the overall bar. So this is a trick to make things look more important than they are. And people regularly use this trick to lie to people. So yeah, this is what it looks like zoomed out, okay? So you can see that there's not much difference between those, whereas this makes it look much more important. Sorry, I should use the pointer. This makes it look much more important than this. All right. I don't know what this is saying, to be brutally honest, right? I mean, the overall nature of this graph is so complex and it has aesthetics that make it almost impossible to interpret. There's a lot of cruft, is what this is called, chart cruft. Okay, so what is chart cruft? Chart cruft is stuff that gets in the way visually of a clean understanding. Okay, so the fact that these things which are indicating to us the proportion of vegetarians, right, are embedded within a map is great, right? We're talking about where in the world it is, but how it's done is not useful, okay? Right? You're not taking advantage of the map. What you're having is you're having a very busy visual element that's small and therefore difficult to interpret, okay? So you have an aesthetic and interpretability problem. And you're layering it on top of this map to give you a sense of visualization of geography, okay? You know what would be a much better choice here? If you just actually colored the outline of this state of India, or not colored the outline, colored the interior, and you colored the area of it proportional to how many are vegetarian, green, and how many are not, red. Okay? That would be a less busy representation of the same geographic proportions. So that's a kind of cruft. Another kind of cruft is stuff that just doesn't belong, that has no real use, that just gets in the way, like these big long lines. Okay? There are different ways to do this. Okay? Also, having terrible background colors is very distracting. Choosing a case of highly contrastive, but very difficult to interpret. There's all colors makes it very hard here. Okay, so there's all kinds of aesthetic details. Yeah, I don't know what kind of visualization would fix this. Fundamentally, this is one of those things that is clearly so complicated that it requires studying it for several weeks all on its own, right? Not the kind of thing that you want to build a viz out of at all, or if you do, you need to walk people through it piece by piece in some fashion to give them a chance to absorb it. So, let's do a few iClicker quizzes. Okay? So, given the things we've just said, things you should and should not do, does this viz pass muster? Not even going to ask you why. What about this one? All right, let me go back through these now that everybody's had a chance. So, does this one pass? No. Can I hear what's anybody? Okay, there's some chart cruft here. So that's one reason, right? I mean, but in a sense, this isn't bad chart cruft because the icons do convey graphic information that's useful because it's about what the whole thing is. But yeah, you could do without them. All right, that's not it. Yes, you're right. You in the back. It doesn't add up. Okay? Or sorry, it doesn't add. My bad. It doesn't, it's not that it doesn't add up. It's that apparently the salt people are less than half, but yet somehow they take up more than half of the area. So there might be a problem in building that graph. How about this one? Does it pass? It's a little bit, it takes a lot of adding to make sure it adds up, but I think it does. And in fact, I think it's a relatively well done graphic. There is a fair amount of chart cruft here that you might not like. So there's the coloration thing is a little, let's call it, I'm going to use a Britishism. It's a bit twee. Okay. It's kind of, it does represent rare to well done, clearly. So, but it's kind of chart cruft for chart cruft's sake, right? There are publications and reasons to be all cutesy, and there are times when it's not a good idea to be cutesy. So you have to watch out for that. But fundamentally, I think this is a solid visualization. You can argue about the aesthetics. So I would give this one a passing grade. So does this one pass? Yeah, you're right. Yep. Look at the two axes. They're not really comparable at all, right? So the US one is like more than 10 times the German axis. And the US one is not rooted at 1. So the two axes are just not comparable at all. So no, the contraction of the US axis starting at 60 trillion makes this small deviation look much bigger. And the lack of comparison of tens versus ones of trillions is a big, big deal. Now there are reasons to do that, but you've got to be sure you're doing it to show those kinds of reasons and not just to fool people. Now this is maybe my favorite because there's a strong indication that this one was an on-purpose attempt to fool people. Back in the spring, there was a big hubbub in Florida where the data scientist in charge of coronavirus information in the whole state was fired, and it was kind of a cause celeb among data science people that she was likely let go because she insisted on reporting accurate figures, and she maintained that she'd been asked multiple times to fudge the data to make it look like that Florida was doing better with coronavirus infections than it was actually doing, and she was getting political pressure to lie, and she refused to do so. And so she took to Twitter and got a lot of data scientists on her side, and then when she was eventually fired, the next time the data was released to public news consumption, it looked like this. So in this graph, what's wrong? Do you see the mismatch between numbers and bars? Yeah. So this is either absolute incompetence or an attempt to make something look much different than it actually is. Either way, not good. Okay, and here's another example, also where on a news program, shock of shocks, there's something misleading. All right, so the unrooted graph phenomena starts at 155,000 there, which again makes potentially small changes compared to the numbers involved look much, much bigger than they actually are. Okay, now, before we go on to the next section, I do want to show a few things that I recommend. So the unrooted chart thing, actually, that we were just on, I shouldn't have left it. So this is such an old problem. This is an old favorite of mine. It's from what, like the 1950s? I forget all. You might be shocked to find out that it is still relevant. 1954. Okay. So here is a totally, whoops, wrong page. Here is a totally reasonable chart. It starts at 0, right? It shows a trend line. Here is the unrooted graph problem, right? Oops. So if we do, it's so hard to do this mirror image. Sorry. Right? So if we cut things off and we start way up high, it might look like this trend line is much more impressive than it is. Or we can be totally terrible and stretch the axes and make it that same graph look really amazing. Okay? So 1954 calling for Fox News and CNN that this happens all the time still. This book is a very fun read. It's definitely worth your while before you even take your first stats class. You can find things, old copies of it, on eBay or whatever. And also has an interesting history. The guy who wrote it, Darrell Huff, he later used his statistical skepticism not for good but for evil. So he was one of the main people out there denying that smoking caused cancer in the 50s and 60s. He was paid to do his shtick about how easy it is to lie with statistics. So just goes to show that one can know right techniques and apply them wrongly. Okay, another thing to show you is books by this gentleman, Alberto Cairo, are an excellent place for you to start in general about visualizations. So he does most of his work at like the infographic level, personally. But this one is just one of several books that he's written about how to make really useful, communicative infographics. So I kind of like this one. It's quite a good one. All right. In general, this one is going to, I'm pretty sure this shows up in a later lecture. So, all right. One other thing that you can take a look at is a classic in the genre. If you're ready to read ahead, go find yourself a copy of Edward Tufte, Tufte. I have one. I can't find it. Tufte's book, The Visualization of Quantitative Information. It's our Bible, I guess, on data viz, right? So, and we'll be using a lot of Tufte's examples as we go through this course. All right. I wish I knew where my Tufte copy was. I lost it. Anyway, we got to get on. I'm running out of time, and we've still got a few more things to cover. So, tables. Let's make sure tables are done right too, okay? Don't make people make comparisons across rows. It just doesn't work naturally. We are much more inclined, both conventionally and for reasons of the way our visual system works, to make comparisons going down than across. Okay? So if you're going to compare things, compare downs. Okay? Arrange rows logically. Who knows what this is? Random. Okay? What about longest delay to shortest delay? That makes more sense. Use those, remember the data wrangling? Use that arrange. Group by mean arrival delay. Arrange. Okay? Sorry, select mean arrival delay. And then arrange. My bad. I said that wrong the first time. So arrange these things logically. We tend to assume conventionally that, the unique thing is over here on the left. This is the unique thing, is the leftmost column. Okay? So this is the name of the airport. This is the person's name. This is the patient ID, the unique ID for the patient, right? Whatever we are talking about the leftmost column is going to be the unique ID. Okay? So don't do something like this. Don't try to stuff too much data into a table where you can't see it, especially if you're old like me. Make sure that column labels are informative. I don't know what AC is or MAD. Okay? Tell us what each variable is in the headings of the table. Don't give a false sense of exactness. You may have that number, but you know it's meaningless. On the arrival of an airplane, when exactly are you counting from? Right? So certainly not at the level of, say, what is that, like hundredths of a second stopwatch level? Not important, not useful. It's both cluttering and makes it hard to read, and you're giving people the false impression of the exactitude of your measurement. Maybe, I'm not sure if any of you have ever had much kind of engineering sort of training, but significant figures are a super big important thing in the sciences, right? When you do mathematical operations, you start with knowing how precise is your measurement, and then when you have to permute numbers by putting that measurement through operations, those are going to gain you or lose you significance, and you need to make sure that at the end of your long calculation that you represent the numbers with the same number of significant digits as went into it. Not a topic for this class, but just a shout out if you know what I'm talking about. Captions, captions, captions. Like I said, the CEO is never going to actually read the text. So if he just glances at a figure and a table, then the table has to actually tell him what it's about. And it's always good to make a shout out. How did this come here? What is the source of the data? You know, people reading this in the future may want to go check for themselves. Okay? So overall, just format it cleanly and quickly so that you can quickly understand it. All right? So that's all I had for today. I only went 2 minutes over. Thank you for staying with me. I wish you the very best of luck on the midterm on Monday. If you have questions, please ask on Piazza. Okay? Talk to you later.